We're looking to find how much a certain alloy will expand, and there's a pretty basic formula for this that we want to remember. The expansion of a material due to a change in temperature is equal to the coefficient of linear expansion, alpha, multiplied by the base length of the substance, multiplied by its change in temperature, the change in temperature that is causing the expansion. The problem first tells us that the coefficient of thermal expansion for this particular alloy is 0.20 times 10 to the power of negative 6 inverse degrees Celsius. We're also told that the length of the table is 1.8 meters, so multiply by 1.8 meters. And we're directly told that the change in temperature is an increase by 6 degrees Celsius. If we put this into a calculator, then we find a change in length of about 2.2 times 10 to the power of negative 6 meters. And that's the answer to the first part of the problem, but the problem also asks us to compare this to if the table was made out of steel instead. So we'll use the same formula again, but we're going to use a different value for alpha. I'll call this delta L2. So you can look up in a reference table that the coefficient of linear expansion for steel is equal to 12 times 10 to the power of negative 6 inverse degrees Celsius. Again, we multiply by the same value for the length of the table, 1.8 meters, and the same change in temperature, 6 degrees Celsius. And if we put that into a calculator, then we find a change in length of about 1.7 times 10 to the power of negative 4 meters. The problem kind of vaguely asks us to compare these two values. If you want, you can find a ratio of the two different values that we measured. So what I did was I took the values that we calculated, and even just the values we put into the calculator, to make sure that we're preserving as much of our significant figures as possible. And when I did this, I found that the ratio is actually exactly 60. So the change in length for the steel table is exactly 60 times the change in length for the super Invar alloy or whatever. Of course, I do want to point out that you only get this perfect value if you're preserving all your digits of precision. I also tried finding the same ratio just by taking our rounded values, and I ended up getting a ratio closer to like 77. But yeah, I'm not sure if that's what the problem wants. I think this 60 is good enough, or just simply calculating both changes in length. But either way, that's it for this problem. I hope this video helped you out, and if it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I hope you all have a lovely day. Bye-bye.